So the work energy power questions could be made slightly tricky, complicated by hiding some information and then asking you to find some other variable, which initially you might find difficult to understand. So here is a question which says exactly does that basically, right? So a block of mass 2 kg and initial speed of 5.4 meter per second slides through a rough horizontal surface, right? So it's a block that is sliding on this rough surface, okay? So initial velocity is given, which is 5.4 meter per second, and it is towards right. Its mass is 2 kgs, right? And finally, it is brought to rest, okay? Which means to bring it to rest, some force must have acted in the opposite direction, and as you know, that force is going to be the friction force, right? The friction force always acts in the opposite direction to the movement. This is our friction force, which is acting, and it is going to stop the object, okay? So we need to find this friction force, right? So now see, when you look at the work energy problem or the definition of work, the work has force and displacement, okay? And this happens to be equal to the change in kinetic energy, okay? So what we are going to do is that usually the right side is given, right? And then you have to find this and basically then find the force, right? So that's how you can formulate a question. This is exactly what this question is asking you to do, okay? So it is moving with a velocity of 5.4 meter per second, and then it is going to go stop and then comes back, and then we have to find how much the work the friction force has done, right? So clearly the friction force is always acting in the opposite direction of the block, right? So which means the work done by the friction force is going to be negative. Why? Because the friction is acting in this direction and my displacement is in this direction, right? Directly opposite. So our cos 180 degree is going to be negative 1, and the friction force does a negative work. Because of this negative work, right, the object loses its kinetic energy from the initial value, right, to final value, which is 0. Okay, so let's start by finding this change in kinetic energy first, so that we can get this part to start with, right? So my kinetic energy change is going to be K final or Ke final minus Ke initial. The final kinetic energy is 0, right? Because it has a 0 speed here now, okay? And the initial kinetic energy comes with a minus sign, half m, which is 2, and v square, which is 5.4 square, okay? So let's calculate that. So this will cancel out, and basically we'll end up with minus 5.4 square there, okay? So this is 5.4 into 5.4, and that is 29.16 joules, but this is negative, okay? This is a negative quantity, and that is the nature of the friction force. Now this is whatever this 29.16 is going to be also equal to the force dot displacement, right? And this is going to be minus 29.16, okay? As you see, the friction force is acting in the opposite direction, right? So when we open the dot product, basically we get F into dash into cos theta, and theta, in this case, the force is acting in the other direction, and this is the displacement. The theta is going to be 180 degrees, so this is going to bring the minus sign to the left as well. So Fs, right, cos 180 degrees minus 1 going to be 29.16. So we getting rid of the thing, and you have to find the friction force. Basically we have to find the displacement, okay? So we have to find the displacement. So let's look for the displacement. Actually it is given in the question right away, so we can use that, right? So it says is eventually brought to rest after traveling a distance of 4 meters, right? So this displacement S is also given to be 4. So we're going to simply take that and put it here in our 29.16 divided by 4 meters, and that is going to be the value of the friction force, okay? So that's now simple, 29.16 divided by 4, and that is 7.29 Newton, and that will be our answer.